You can hand that to me.
So greetings to day 2. So thank you guys for being here. As we sent earlier, if you're presenting on a day, you should be here for all the presentations of that day. So everybody that's presenting Friday, if you run into those team members, tell them, sit there for all the teams presenting Friday. Just politeness. You want to hear each other talk. So I think it's a good thing. So thank you guys for being here. Thank you to any clients, to any visitors we have. This is our Halves presentation day 2. Lots of really interesting things going all over the place, and I can't wait to actually hear what's going on with these projects. We're going to get started. What we're going to do, in case you weren't here on Monday, we are going to break after 4. So after 4 projects, we're going to get up, stretch, only for about 5 minutes. Okay? All right, good. Let's get started with mic check.
Thank you. Mic check. 1, 2, let's go.
Face the AI, steal the show.
Test your skills, make them see. Who's the boss on the MIC?
Write your best, battle for fame.
Rhyme writers go.
On the game. Woo! Okay. Thank you. Thank you. Hold your applause. Hold your applause. Okay. Good afternoon. Hopefully you're awake now. We are Mic Check, and our team consists of 6 members: Hazel, Keisha, myself, Samantha, as well as Candace, Emily, and Isabella. So this is a faculty pitch project by Mo Maller and Jonathan Walton. We also have some wonderful SMEs, Charlie, who is our AI expert, and Ken Njuku and Stillman IT, which are our RAP experts that have been helping us throughout this semester. So we want to leverage generative AI through RAP to empower players to express themselves creatively and have fun. So our game is a single-player experience on PC, and we're targeting 15 to 25-year-olds. We're also using ChatGPT 4.0, which is a pre-existing model. So we're going to do a short live demo for you guys of the 2 main sections of our game, the pre-battle and the battle stage. So in the pre-battle stage, you'll be able to gain information about your opponent, and then you'll be able to construct raps after that. So the good thing about generative AI, what makes it interesting, is that everything is fresh and new, nothing is scripted. So I'm going to ask you guys to give us a prompt that you want to ask the AI. So what's one thing you would want to learn about your opponent before you rap battle them? Somebody please answer. Where are you from? Great. Great question. So our opponent, Flagel, you've gone up to her and you say, she's like, can I help you? You say, where are you from? And she'll say something like, San Fernando, California, babe. It's the place to be if you want to vibe like me. And the conversation will continue like that. But let's now go into the battling stage. So once you gathered all the information, you'll be able to battle your opponent with the fill-in-the-blank feature. So Flagel's going to go first. Please bear with my terrible rapping skills. So it's Flagel. I'm dropping rhymes like a shower. From the Golden State where we own every hour. On the subway, I'm the queen. Ace, you know the power. Watch me bloom while your style starts to sour. Okay, what are you gonna write? So I'm gonna take 2 answers here. What's one thing you want to boast about and one thing you want to diss about? Pittsburgh! We want to boast we're from Pittsburgh! Thank you. And what's one thing you want to diss about? Sorry? Potholes. You have a lot of potholes in California. Potholes. No, pee. Okay, great. And then once these topics... Once these topics are given, we're going to generate 4 bars, incomplete bars, that you will then have to fill in. We're only going to fill in 2 bars for the sake of time, but from Pittsburgh to the top, I'm repping the blank. While you're stuck in the road, tripping on those blank. Where do you want to put the first one? I'm repping the bridges. Okay. Great bridges. While you're stepping in the road, tripping on those ditches. Love that. So this is how one of the rounds will go, and we're not going to do the rest, but then you'll be able to submit them and get a scoring based off of that. Just submit it. Reactions. And we'll kind of go into detail later about how all the scoring works. As you can see, the scoring at the top is for you guys. So thank you. Give yourself a round of applause for her demo. Now let's get some details of the project.
So getting to our project goal, we are trying to create a game that challenges players' writing skills by pitting them against AI rapping opponents to emerge as the rhyme writer. To guide our development and design process, we have been following these 3 pillars. Starting with gameplay, we have been trying to center all our player verbs around write, whether it's interacting with the AI NPCs or constructing a rap against them. And we are providing scaffolds for creativity, like objectives, constraints, and content that you can write about. Our second pillar is generative AI, which is a technology we are designing this game around. We are trying to leverage its strengths and empower where it's good at, and work around its limitations to make the experience good. And we are also using it to make compelling characters so that the experience is motivating and the battle is engaging. Our third pillar is rap culture itself. With our experience, we are trying to tap into the rapper fantasy, which allows you to write like a rapper and battle against opponents. And we're also borrowing elements from rap battles and emulating what makes them exciting and engaging.
So speak of the hip-hop culture, we did a lot of research on the history and how its culture developed. And rap battles is the part we want to focus on. Among all the style of hip-hop, we would like to focus on G-Funk as the first level and make players battle several opponents to win their respect, to claim a title, and get confidence by completing rap lyrics that rhyme. For rap battle research, we then found and watched rap battle shows include pre-written and recorded rap battle like epic rap battles of history, live show performance like Whiting Out, also film like 8 Mile. We also went to a rap battle together in Club Elegance. We all feel the atmosphere and amazed by some of their wordplay. And we also collect sound effects and visual elements to implement in our game later. Here are reasons we choose G-Funk as our first music demo. This style has a profound history and a laid-back, funk-infused groove, unique style that distinguishes it from others. And as a chill and relaxed style, it is easier for players to accept as the first level. We use Grand Theft Auto from GTA 5 and sounds from artists like Snoop Dogg as reference, gather sound effects from them, and then make the demo you already heard.
Speaking of the game goal, it's all about being the rhyme rider, which means a group of rappers rapping in the underground. Players will use rhythm and wordplay to claim turf and rise as a rap legend. The player character is Ace, who is an energetic and passionate dog who grew up admiring the rhyme riders. Inspired by the way rap allows for fun and creative self-expression, Ace is determined to prove themselves in the underground scene. And when designing Ace and the other characters, we want to reflect the elements of hip-hop culture through fashion, personality, and stylization. Instead of using human characters, we went with anthropomorphic animals to give the world a unique, expressive style that feels fresh and inviting. For the outfit design, we took a lot of inspiration from real-life hip-hop streetwear. The colors is often high contrast and bright, such as yellow, gray, and red. The oversized jackets, hoodies, sneakers, and accessories are also reflect elements of the classic and modern hip-hop fashion. And here are some references we get to our art direction. We are inspired by games like Splatoon and Persona 5, as well as some real-world locations such as NYC Subway. For Splatoon, we like its bold colors and stylized characters. We want our game to have a similar look and dynamic. For Persona 5, its high-contrast color palette and stylized subway aesthetics. This influences how we want to design our environment and UI. And for NYC Subway Station, we think it's a major hub for culture and music. That's why we want to put our similar background settings.
Getting inspiration from the previous games and real-life settings, we designed the game to take place in subway station, which reinforced the underground theme. Main characters Ace travel via train across the different parts of the city to battle different rappers, which makes the subway both a hub and a battleground. To enhance their energy and atmosphere, we designed the subway stations with neon lighting, high contrast colors, and dynamic elements to make each battle stage feel alive.
And our world is also filled with visual storytelling elements, such as posters, graffiti text, and different lightings. All these reflect the identity of each rival rapper and different districts of city.
Our game loop includes 5 stages: intro, choose battleground, pre-battle, rap battle, and win and lose condition. Entering the game, we have an intro with some narratives to tell the player the background story of our game, the game goal, and the player's role. After that, players can choose a battleground by selecting a stop. They will meet opponents at different stations, each with its own rap style. Players must unlock stations one by one, meaning that they cannot access further stations until they pass the previous one. Additionally, stations are replayable since AI raps differently each time.
So once at the station, as you saw in the demo, the player will be able to prepare for battle. So they'll be able to talk to the audience, look around the station, and talk to their opponent. And this is where this is an attempt for them to kind of collect information that will help them score well. So it's like looking up your opponent. Then the player can initiate the battle. So they'll be able to enter in topics that they want to boast about and disavow, and then using that information will generate incomplete bars that they will then fill in and then complete, and that will be scored later. And once they do all of these things, beat all the components, they'll be able to win the game.
Coming to the part which is leveraging AI in our experience, these are the 4 components: the rapper opponent, the scoring system, the audience reactions, and the writing assistance. We'll get into detail for all of them now. Starting with the rapper opponents, to make a rap battle feel challenging and exciting and make the victory feel worth, the opponent has to be alive and they must have a dynamic personality. So we are leveraging AI to create a very authentic personality which can adapt to players' inputs and give you adaptive responses. Our first character is Flygirl, a rapping seagull from San Fernando who was propelled to success by her previous sister's fame. As we are using a pre-existing model for our experience, we had to use prompt engineering and responses to train our character to talk the way we wanted it to. There are 2 components to it. The first is the character context. This is where we feed the AI their behavioral traits and reaction tendencies, like you talk with a relaxed drawl like a valley girl, or you are insecure about your inability to fly so well. And then we use chat responses to reinforce these behavioral traits and reaction tendencies. We have also provided with rap examples, which determines which kind of content they rap about, which kind of rhymes they go for, and which rhyme sets they employ.
Our second AI element is writing assistant, which helps players craft lyrics based on their own idea. So we design different writing modes, so no matter you're a beginner or a seasoned rapper, the AI enhances your creativity, making it fun and easy to construct engaging bars. Now let's talk about audience and scoring. A rap battle needs a hyped-up crowd to bring it to life, so we design AI that dynamically generate audience reactions, cheers, or even boos based on performance and the audience preferences we defined. So this adding a new subjective layer to the scoring, which is closer to real-life rap battle. Beyond battles, AI also creates rumors and gossip about your opponent rappers, which will be added into the interactions later, building a living, evolving world around rap battles.
We also went to several playtests, such as Tuesday night playtests and SME playtests, and we gathered valuable feedback on what's working and what needs improvement. One of the biggest success was the high engagement and motivation. Players found the game is fun and competitive. Many are really invested, and this reinforces that our mechanics are interesting and workable. Some of the key issues we need to address, including there are too many questions being asked by AI, and the AI is always giving too long responses. We also need more indirect control to guide players smoothly, and that's why we want to add the rap inspiration book as a system.
Our next step focus would be on iterating based on this feedback. We are refine our scoring system, adjust Flygo's personality profile, and introduce more interactive elements such as audience, NPCs, and additional battle modes. Oops. Sorry. Yeah. Okay, thank you. Now we are open for feedback and questions.
Actually, we want to mention one more thing about the scoring because we have 2 minutes.
Yeah, so this is a part that I feel most challenging about.
Whoa, who's clicking?
Yep.
Okay.
Yep. So traditional games often rely on hard-coded rules to score different mechanics. However, rap battle involves like complex and contextual elements that makes traditional rule-based scoring extremely difficult. For example, what one rapper said influences how the other should be judged, right? So that's why contextual understanding is required, and this is exactly what AI is good at. So we design our AI scoring system that evaluates clarity, story consistency, this effectiveness, and even audience reactions, scoring players based on the metrics we defined. Yeah, just clarifications.
Yeah, sorry, we had a clicker issue on that one. But thank you, and we are now open for questions.
Remind me again real quick, your audience is who?
15 to 25-year-olds that don't necessarily have a rap skill, but are interested in learning about rap.
So all of the rap text that you have is written, right? Have you found during your playtests that people try to rap it aloud, or is there anything that you want to do to encourage that behavior?
So that's something that we thought about kind of in the early stages, because rapping is the main thing about rap is you get to perform it, and a lot of the reactions are based off of that performance. Since we're a text-based AI, how do we kind of get that back? It's something that we're still going to iterate on as we continue on the design, but I don't think anyone's actually said the raps out loud, maybe except for our SME, I think. Yeah.
But I will say that there are people who express interest in recording their raps and sharing it with their friends and stuff because they wanted to show off what they've written. Yeah.
Any other questions?
So are people registering as Ace and as the character you're showing? And is it important to see myself inside your rap experience?
About Ace.
What was
Do they know I am that character, and are you going to keep showing me as that character?
In our later development, we decide to let player input their names and some very simple background like jobs or titles or anything like that. So we provide a more engaging experience for the players.
Will you change the art then based on that input?
Yeah, we are planning to do multiple models for outfit models for the players to choose in the future.
Okay, this isn't exactly a question about replayability, but I was wondering how the AI model handles the same inputs over and over again. Like, for example, we wrote that we wanted to rap about Pittsburgh. If we had done the same thing, the same exercise a second time, are we going to get really similar results? Will the rap feel samey if two people put the same thing in?
So I don't think two people inputting the same thing in the prompt would get exactly same sentences, because the AI generate your bars based on the whole conversation and whole interaction you had before with this NPC. So every conversation history is stored uniquely with your player ID. Yeah.
Cool.
That's all right. So this is definitely a novel experience. We've never seen anything quite like this, but it opens the question of, if this were to be a product, what kind of platform do you think it would work well on? Because I think the concern with it is, well, okay, this seems cool for a few minutes. Is the gameplay sustainable? How sustainable is it? And what platform is it a best match for, do you think?
Well, currently it's only running on Hazel's computer because you could probably talk more about kind of like the cloud server and kind of access to ChatGPT. We did take some time. We had to get like a certain like licensing for the AI, and we like even in the testing stage, you do have to allot a certain amount of money to use like the APIs as well. But in terms of running, it would have to be on a server, right?
Yeah, so for now, most of the like AI games company that make AI games usually facing a challenge is because API calling itself like.
I get where you're going. That's not what I'm asking. What I'm asking is, if someone's going to buy this game, is the player experience. Of course, it's going to be an AI running on a server. Yes, absolutely. There'll be tokens, the whole thing. But will the player experience be best suited to Steam, to the Switch, to mobile, to a web game, or have you not thought about that?
Like originally we think about web game because I feel like this format is great for like maybe YouTubers, those streamers to like play online and record reactions online. So that would be fun. And
Just to add to that, when we were doing our research, we did look into what AI games are popular, and most of them have been on PC because I think AI is good at using text, and like that's the main thing. We did see a couple of VR games. There was like this one VR game where you're like the only human against other AIs, and the AI has to figure out which one's human, and that was a really interesting thing. But I think as of now, what's been most successful is it being on PC.
Okay, thanks. That's time. Thank you.
Sorry. Who's next?
Xhaler.
Yes, I can take. I was.
Good afternoon, everyone. We're Team Xhaler, and welcome to our Halves presentation. This is our team. I'm Jack, the game designer.
I'm Jing, the programmer.
I'm Alex, 3D art and design.
I'm James, the other programmer.
I'm Lawrence, 3D art and tech art.
And also our amazing project instructors, Dave and Charles. Our team's goal is to enhance immersion in VR games by incorporating breathing as an interactive mechanic. So why is this important? Well, the combination of breathing and VR meditations has been around for a while. Their potential in the field of entertainment, especially games, is largely unexplored. So we believe that combining VR with breathing-based interactions can bridge the gap between our mind and our body and unlock new possibilities for immersion and engagement. So based on this, our target audience are players who are eager to explore alternative game controls and players who are seeking a deeper sense of immersion in their gaming experience. However, as a highly unexplored field, there are very few games and resources that we can rely on. So how are we going to achieve our goal? Our strategy looked like this. We begin by breaking down breathing into its fundamental component, specifically breathing patterns, which includes inhale, exhale, hold, shallow breathing, and so on. From there, we identify breath-driven actions that closely align with these patterns to develop our own prototypes. For example, the pattern we want to explore here is hold. And for the prototype we're making, we're choosing diving, which challenges the player to hold their breath underwater to avoid enemies. Through the process of prototyping and playtesting, we gather insights, refine our understanding of both player interaction and breathing patterns, and combine these lessons learned to the context of a game, which is also going to be our final deliverable, a combination of various prototypes. So to be more specific about our deliverable is to complete an action-adventure VR game using breathing as our core mechanic. It will consist of a single level map and with approximately 5 sections. For each section, player will engage in different breath-driven actions to solve puzzles and complete challenges. This is our game flow. The game begins with an introductory story, followed by a series of different challenges and puzzles, including sneaking, archery, diving, and so on. Players will learn to utilize different breathing techniques to overcome these challenges and progress through the game. So as you can see here, these are some of the prototypes we did. On the left, you can see a locked door. On the middle, you can see diving. And on the right, you can see archery. We'll talk about them more specifically later. So back to our strategies. What exactly are our design goals and tech goals? And how do they help us in improving our game?
So let's break it down into 2 parts. And we will talk about design first. So our goal is to enhance immersion by using breathing as a mechanic. But we also want to preserve the comfort because discomfort might break the immersion. So how do we enhance immersion? Well, we examine immersion into 3 different angles. First, cognitive, and then emotional, and then sensory. Talk about cognitive, it means how much players can consciously control the game through their breathing as a mechanic, which make them feel more connected to the game. So we've developed 3 prototypes, which is diving, archery, and rocket. The cognitive level goes from intuitive to intentional. And from the diving prototype, we found that this is very immersive, and players feel very intuitive to use the breathing mechanic. But there's a problem, because it is too intuitive to make players will naturally hold their breath when they're underwater, so they forgot the breathing is exactly the game mechanic. So our challenge is to balancing between intentional and intuitive to create our breathing mechanic. And we also try to put some diegetic feedback into our game, such as here. We synced players' breathing with a glowing effect of the vine, and we also plan to apply some mechanic to let player can generate wind to affect the object in the scene. And here we are trying to put some intentional rules to our prototype. So as you can see here, for archery prototype, we decide a rule that if you hold your breath for a while before you shoot the arrow, you can generate a power shot to actually knock down the enemy. Otherwise, you cannot hurt them. So this is our approach from cognitive side, and I will let Alex to talk about emotional side.
Thank you. So the start of our experience, you are in a lab, and you have to complete a bunch of calibration. So we're trying to match a lot of the interactions into the story, specifically. In this video is the start. And the player is asked to stand while there is a panel that will have the syncing. So we feel this approach is better emotionally because we would like to have the immersion be part of all of the mundane tasks like the calibration. It makes it feel a little bit more like it's part of the world and what you're doing is meaningful. As you can see, the player is matching the breathing pattern to calibrate it. That was successful. And this is a failure. This will go on until the player knows the breathing pattern. So you see the glowing tubes, that's another part of our diegetic feedback, where we have the breathing sensor connected to the opacity, as well as the emission value of the facility to give a little bit more feeling like you are part of the environment.
Warning, facility
In the start of the experience, you are discovered by the embodiment of wind in the Wind Temple. You start in this facility, but then it instructs the player to walk out of the facility to start the game. Here's Jing walking. We also like connecting breathing to the different level sections. So in order to get to the next level, you have to place your hand on this panel and then breathe in until it fills. So as we develop this project, we are trying to tie the narrative specifically to the prototypes. And we feel that's best because then you can have a better realization of what your body's doing in it, and it also feels correct. So one of the ways that we achieve this is a user journey map. We specifically found in the prototypes via playtesting what emotions are felt per one of the interactions. So as we develop the story, we would like to develop the narrative so that those tense moments are met with tense, like a lot of enemies fighting you, and serving that, in the climax. We also are using haptic feedback as well as surround sound in order to help that.
Thank you. So while our devices and mechanism achieve immersive gameplay, we already have several approaches to keep our target audience comfortable. Three main directions of our development based on concerns are solving the problem of motion sickness, enhancing player safety, and keeping a reasonable game pace to avoid player being too tired. And we also have videos to support our approaches. To solve motion sickness, we have discovered and confirmed the locomotion design as the main physical movement type out of several other ways, such as teleporting and controller movement. And they have specific terms for this in researches, which is moving place and walking place. And doing the same action in both physical and virtual world largely help reducing the motion sickness based on our own playtest and existing research. And here's another video of the diving prototype with some approaches under development. Based on the playtest, some players found it too immersive that they temporarily forgot they wouldn't actually drown. And this actually indicates that the connection between the breathing and the game environment was highly effective in reinforcing a sense of danger and realism. But however, this level of immersion also causes nervousness and hesitation among players, which should be further explored to balance the tension and comfort in future iterations, such as smoothing the process of going into water and reduce the stress by more friendly visual elements and UI.
For the pace of our game, we have consulted this gentleman over here, who has written an academic paper about breathing and game interaction. The key takeaway from him is that we wanted to design our breathing interaction to only happen one at a time instead of letting the player to trigger multiple interactions simultaneously. Why we want to do that is because this will significantly reduce the cognitive load of the player and also enables the player to know exactly what kind of interaction he wanted to do and how it empowers them. For a tech, we mainly focus on accessibility and stability. Throughout multiple rounds of playtesting, we have observed that players breathe from belly and some other players breathe from their chest. So if we put our sensor incorrectly on the opposite position, it will detect the results wrongly. So our solution to this is to put it somewhere in the middle ground, the rib cage area, that will be suitable to either kind of the users. And for the build itself, we have upgraded a couple of times from the initial Arduino stress sensor we handmade to now we have a commercial built product that can transmit Bluetooth signal wirelessly. And we'll be coupling that with a wind sensor that can actually detect the airflow around the player's mouth area and to use that in our future blowing interactions. So for future plans, so far we have built more than 50% of the building blocks for our final deliverable. In the second half of our semester, we wanted to finish the rest of the building block, but more importantly, at the same time, we want to put these building blocks together into a cohesive narrative experience, which will begin with the intro level we just watched together. And yeah, that concludes our Halves presentation. We are the Xhaler's. Thank you. Now open for questions.
It felt like you touched on this a little bit in passing, but I'm interested in the interaction between the breathing dynamic and the player's emotions, because a lot of the times it sounded like you're presuming that players are completely in control of their breath. But if you, for instance, ask them to run, their breathing's going to increase. Or if you scare them, they can't hold their breath, or things like that. Were there any things that you discovered that you could or couldn't do because the content of your game was actually driving what kind of breathing they were having at that point?
I think in our case, our content is not driving the player. It's the opposite way. It's the player choose to use these actions and then affect their emotions. So in the future, we'll also be working towards this direction, which will mitigate the safety issues and the issues that you mentioned.
I'd challenge you to look at it potentially also going the other way, because that's just how humans, bodies are. I can come talk to you later about some examples from other games.
Yeah, thank you.
Can you, I kind of thought, okay, so can you talk a little bit more about why you're introducing navigation as a core aspect of the experiences that you're designing? It seems that it is working against the breathing exercises that are the focus of it. So when I need to walk across the room or run across the room, it just seems like a distraction from what you're set out to do.
So yeah, these are designed in different sections. Specifically, there will be different areas where certain events are happening, where usually the player will either be standing and then focusing on combat, or specifically doing the things like the button for the door, where you have to stand and physically be there. That way, you're not running during.
So for some of the interaction, like diving, we won't be using the walking movement, but like for other, that will be specifically focusing on moving. Let's say sneaking, there's a level that's going to be about that. So we're going to use like how you walk and how well you control your breathing. So it's like very interconnected to each other.
Yeah, one of the reasons that we focus on navigation and the locomotion design is that we do not want to ignore some of the possibilities which involves locomotion, like sneaking, running. If we do not have a walk-in-place movement style, then these prototype designs will not make sense anymore. But we still want to explore them. Yeah.
Can you clarify? I think you guys said that you chose to remove discomfort from the experience because it got in the way of the other parts. If that's so, can you define what you mean by discomfort, and just give an example of how you think it got in the way of what you guys are trying to do?
In the previous playtest, we found that there was some discomfort, specifically from the old belt into the new one. The old one was kind of uncomfortable in the way that it wasn't like a complete system. It was kind of like made. It wasn't a commercial product. This is better for that, and also specifically designing around the breathing not being too holding doesn't last long, as well as forget what the specific what was it on playtest.
From several playtests, we have several prototypes, and each prototype will make players do different kind of action about their breathing. So for rocket prototype is too intentional, because you don't usually using your breath to make the rocket goes up and down. So that prototype makes us know, okay, player will find the breathing mechanic is interesting, but is less immersive because it's too intentional. And from the diving prototype, we just mentioned that is very intuitive and immersion, but we need to care about the tense about the prototype because they are underwater. So those are from tech part, and the playtest part from the design is our main found.
Thank you.
Hi everyone, we are Spelunx. We're so happy and proud to share our progress for our Cavern Toolkit. Our instructor is Drew and our consultant is Mike. We're a team of 6 interesting people, and 5 of us will speak today. One of us currently couldn't speak, but she will drive the slides. Thanks, Terry. Our goal for this semester is to make a toolkit that makes the Cavern easy to use, and so that Cavern developers, including ETC students and also even high school students with varying skill sets, can develop impactful experiences with Cavern. Last week, we held our first Cavern Jam. It was a great milestone for us. Thanks to all the students, faculty, staff who helping us spend time on testing our toolkit, and thanks to all those who come to our showcase. Nothing involves our work better than feedback. This is what we get from the Cavern Jam. I would never have been able to build a Cavern project without the toolkit. Let's get more details of the jam.
For our Cavern Jam, we had 8 participants created 6 unique worlds. Using our first release of the toolkit and the documentation, they developed immersive experiences from scratch, each featuring 1 interaction. The jam was an exciting playtest of our toolkit, and so we're excited to showcase the results. This is 4 or 5 trackers, and they will walk around and try to create like a frog symphony around the space, so it's really cool. What we learned from the jam was that with our toolkit, out of the average 4 hours of development time, the average time to get from a completely blank Unity project to being fully set up for the Cavern was average only 20 minutes. Moreover, our documentation was praised and was easy to follow. On a scale of 1 to 5, the confidence level to develop on the Cavern went from an average of 3 to an average of 4. Look at these people having fun in the Cavern. What we also learned is through the jam, Cavern is inherently a multiplayer, playful space, not just for the person with the 5 trackers, but for everyone in the space as viewers. So what was in the toolkit that enabled those creative experiences? To give a quick refresher from our pitches and quarters, our toolkit includes a Unity package that lets you import and navigate through, an improved camera rendering solution, input integration such as the Vive trackers, surround sound support, a sample scene with interaction and features that you can further build upon on, and finally, comprehensive documentation, including user guides, technical documentation, and living best practices. Now, let's rewind to how we got here.
We started off with extensive user research. Our target user is anyone who wants to create for the Cavern, such as ETC students who have Unity experience but maybe have never built for the Cavern, or South Fayette high school students who are just starting out but are very passionate. Our goal for the high schoolers is to get them from 0 to 1, to let them make experiences that they never could have before. Our goal for ETCers is to get them from 1 to 10 by reducing technical overhead so that they can focus on their creative visions. We've been working closely with the South Fayette High School, giving them our toolkit to use and helping them figure out what students need to learn to start developing for the Cavern. From them, we've been getting feedback about our toolkit, as well as the curriculum that they develop, which we can then give to other schools in the future. One of our important milestones is March 25th, the Digital Promise Conference, where administrators from high schools around the country will be visiting South Fayette to see the cavern and how the students use it. Next, we'll talk about our technical breakthroughs.
Thanks. So let's start off with talking about the camera. This is the old cavern camera setup. As you can see in this panel on the left, when you run the project, there's a bunch of these sub-cameras that show up. For new users and people who are just starting development for the cavern, this is really confusing and overwhelming. Let's talk about why this happens. So since the cavern is a curved 270-degree screen, we can't render to it like with using a normal camera, like a flat screen. Thus, to get the curve projection and perspective correctly, the old camera uses 32 different cameras to render thin slices of the scene that are then pieced together. However, this is really complicated, and it also really reduces the technical rendering performance, and it doesn't allow you to render really nice and fancy scenes. However, this is our current camera. So in this new camera, as you can see in the scene hierarchy, there's only a singular camera, and that does all the work for you. So how do we achieve this? Well, in our camera, we're currently using a cube map. So we map the game world to a cube around the camera, and then we sample from this cube map in order to render to the curved surface. And this achieves a similar effect to the previous 32 camera setup. However, we only have to go through the rendering pipeline once. We are also able to extend this to support stereoscopic 3D or the 3D effect that you see on the cavern. To do this, we use 4 cube maps in the 4 cardinal directions, and based on the direction people are looking, we pick which cube map to use to render from, and that allows us to support 3D in the cavern.
We're also currently experimenting with off-axis rendering, which means that we can render from the perspective of any position in the cavern, not just the center. Combining this with tracking, we can implement head tracking, where the screen accurately reflects how the world looks from where the player is standing. What you see here on the right is our gold spike. Here, a player is walking around the cavern, and the flower appears to be in the same place, but you can see it from different perspectives. Our new camera also has much better performance than the old camera. We ran a comparison in High Cave's test scene from last semester, and as shown here, our new camera nearly triples the performance. Next, I'll pass it over to our artists to talk about how this camera has been used.
Now I would like to invite you to our sample scene. So currently you're watching the sample scene from Cavern. We try to create experience of a spirit exploring a surreal forest with giant flowers with a peaceful and immersive sense of feeling. So here are the assets we created so far to build our sample theme. There are 3 major reasons that we create our sample theme. We want to arouse an immersive sense in our sample theme. To achieve that, we added ambient sound and surrounding sound effects to our theme. And we also added animated objects such as flying butterfly. It flies towards the camera so that it enhances the sense of immersion. Also, we want to demonstrate the interaction of the cavern space. We added scripts of some basic, simple interactions to our art assets, and we also created modular prefabs of that so that our package users can use them easily and intuitively. Last but not least, since we are offering our own render solutions, we want to prove that the enhancement of the performance, we added some art features such as simulations, shaders, and post-process, and grass instancing, and etc. Now let's take a look of how to set up our package.
So to set up our package, you can find it in the Unity Package Manager. So it currently lives under the etc package registry, and there's two packages. One is the core basic mechanics that you need to run any Cavern project, including the Cavern camera. And the second one is an input device, and we're supporting Vive trackers currently. We split the two into two different packages so that our toolkit can be modular, so that if someone wants to add another input device, or if an input device becomes depreciated, people can swap them out and still maintain the usage of our package. Additionally, since this is hosted on the Unity Package Manager, this means that we can push updates really easily and quickly. For example, during the Cavern Jam, some of our jammers uncovered a bug, and we were able to fix it and push a new update to all jam participants within an hour. And this is what our toolkit looks like once you open a Unity project. So our toolkit adds this custom tab in the toolbar called Cavern, and under that are two drop-downs. When you open them, they'll show these two panels, and each panel supports a single-click add interface. So you can add the Cavern setup into your scene simply by clicking the Add Cavern Setup button. Additionally, throughout the process of developing for our toolkit, we're constantly looking at user feedback and implementing it into our design. During our project, halfway through, our artists kept telling us that it was really hard for them to see what their scene will look like in the Cavern, and it was really hard for them to test, which is why we added this preview feature. It adds a Cavern mesh into the scene that is the accurate dimensions of the Cavern and is to scale. And when you click play, it will render a preview of what your scene will look like in the Cavern onto the mesh, so you can see what it will look like without having to be directly in the Cavern itself. And now let's talk about adding interactions and input devices.
Since the Cavern is a very immersive space, we want the way that people interact with it to also be immersive. That means we don't want people standing around using Xbox controllers or keyboards. There are two input systems currently built into the Cavern in hardware, but in the past they had no software support, and every team had to come up with their own solutions for them. We chose to start with Vive trackers, which are devices that you can attach to your clothes or objects, and they'll track your position and rotation as you move around the Cavern. We chose these to start with because they're simple and easy to reason about and offer a wide variety of possible interactions. They were designed for virtual reality headsets, which the Cavern is not, which caused us a lot of issues. So we came up with 5 potential methods for getting Vive trackers to work with the Cavern. The first one is outdated and very, very bulky because it offers a lot of stuff for virtual reality that doesn't apply to the Cavern. The second method worked really, really well, except it crashed Unity every single time. The third method would be great. It was custom designed for the type of thing we're trying to do, except it was designed for Vive trackers with virtual reality headsets, and without a headset, you get nothing. The fourth method works and doesn't crash. Fantastic, but it is still very bulky. But from the fourth method, we were able to reverse engineer why it wasn't crashing and the second method was. We were able to come up with a good solution that is easy to use and not bulky and up to date. So here is an example of what it takes to go from no Vive trackers in a scene to having Vive trackers. And that's all it takes. Next, we'll talk about documentation.
So we created a lot of documentations of our package. We have the user guides of how to set up our package. And we also have the API documentations of our code. And we have technical documentation of the math behind the rendering camera as well for future developers. We have known bug and living best practice for using the package. We give these documentations to our jammers during the Cavern Jam, and they all find those are really useful. Basically, those are the progress that we have so far, and now let's looking forward to our rest of the semesters.
Since we made so many progress, this is what our creators will face before our toolkit. And these are the progress we made. Next are our plans for the after half semester. So first, we will take the advantage of the URP. We're adding more technical art features as we have mentioned before. We want to try shaders, we want to try volumetric clouds, we want to try all the kind of technical art features. And the second, we're having a systematic UI for our toolkit, so it will be more user-friendly and easy to understand. And the third one is the polished modular toolkit. We'll keep doing that. And for our symposium, we want to have like more modular interactions into it, so we can showcase all the features we added to Cavern setup. And we also will, instead of the 3D camera we already finished, we'll focus more on a 2D rendering camera for the game UI and video. And we'll also add a second input, which is the RBAC, instead of vibe tracker. And we'll continue to do the testing with South Fayette and with all the ETC faculties and students. And we'll continue doing the documentation. We can't get to here without all those helpful people.
We couldn't have made it this far without all of the people on the screen. We want to thank Steve and Ezra for answering all of our questions. We want to thank Stacy and her class who we're working with at South Fayette. We will also want to thank our advisor and our consultant, Mike and Drew. And yeah. For the Cavern, there's some things that you kind of have to see in person to experience the 3D for yourself. So we welcome you to come visit us at 1 p.m. tomorrow in the Cavern, where we'll show you our sample scene and also some of the Cavern Jam projects. So we hope that we'll see you there. Thank you so much, and we're ready for questions.
I would have expected that the cube map strategy would lead to distortions on the seams of the cube map, but it doesn't seem that that's the case, or is that the case?
For the most part, the cube map method is not as mathematically accurate as the multiple sampling one, but performance is much better. And what we notice through people being in the cavern is that no one notices. Okay. The cube map method is good enough that it looks like normal 3D to us, and so we've chosen to sacrifice a little bit of accuracy for, oh, yes, one other thing, the cube map method for if you're not doing 3D is actually perfectly accurate. But once you do 3D, then it's just slightly off.
Understood. Okay, thank you.
What is the plan for the subsequent semesters, and particularly when you guys graduate? What happens to this?
Yeah, we have made a lot of decisions about the toolkit, thinking about that, looking forwards. So we've moved to Unity 6 and to Universal Render Pipeline because we expect that's what people will be using in the future, and so it will have more longevity. We also have documentation about all of our decision-making and thought process, so if anything breaks, you can see how we derived everything mathematically. And a future team or a future, like people that get hired by the ETC could fix it. And also a lot of our packages are modular, so if something changes in the Cavern, it's really easy to just replace it with a different package that someone makes.
And also we have a living best practices document where we want to pass on some of the knowledge that we have making experiences for it and designing for it, so that future teams can learn from our mistakes and our experiences as well. And we hope that that document continues to be maintained by future Cavern teams so that we can compile and build institutional knowledge.
Do you find with the cube map method that you're giving anything up, such as post-processing effects that rely on depth?
No, everything works. Terry is the one who did pretty much all of the work on the camera. Unfortunately, Terry can't talk right now, but should be able to talk soon. So if you want more specific information about that, then come by us in the next few days.
And also, just shout out to Terry's technical documentation. She included all the math behind it, so for the future developers.
So you mentioned that South Fayette has a big date of March 25th, which is coming pretty quickly. And then you listed a number of things in your next. Are there some things in your next that you want to do to help South Fayette have a good showing March 25th? There's just some priorities for the next few weeks.
The South Fayette students are because they're beginners, they're more focused on creating like atmospheres in the cavern with some basic interactions. So a lot of the things that we listed here, polish and documentation will help everyone. The 2D rendering is more for the other cavern team and for future cavern teams, same with the Orbeck. But one thing that we do intend is to build out our interaction system. We have some scripts already that we have provided to them that they can build interactions off of, and we want to flesh that out a little bit more so that they can write less code.
Maybe I missed it, but I don't see the surround audio piece. Did you just say that was out of scope, or how's it going?
We had no time in our presentation to talk about it. But if you want to share.
Surround audio works. We found that the computer has to be set up to 7.1 and then disable the two side speakers, and then we will be left with 2 front, 2 rear, and also the middle one doesn't. The center speaker that usually can be virtualized, it's not really obvious if it's on or off if it's in the cavern. And that's it, I think.
Yeah, and I also wanted to mention in our like one-click setup, it not only adds like the camera and the prefabs to your scene, it also like auto-configures some of the settings in the background, and that includes setting the audio to be the correct stereo mode so that you can have surround sound.
And that's time. Thank you, team.
Hello? Who?
Okay, so hi everyone, we are Team Breakbone, and we are here to present our project we're currently working on, which is called the Project Hybrix. I would like to introduce our members first. So we have Iris and Amelia as our UI UX designer, and we have Ethan and Steven as our programmers, and we have Olivia and I as our visual development artist, and also Steven and I are the co-producers. Behind our team, we have Scott Stevens as our instructor, and also ETC K-12 as our client. We also have a company called Play Included as our subject matter expert. Before we dive into our project, I would like to introduce you the Break by Break program, designed by the Play Included. So this program is an evidence-based and effective program. It's basically about letting people build in the same Lego set with multiple players, and the players will be divided into multiple roles, such as the engineers, the engineers, the supplier, and the builders. So these players have to work together, collaborate, and communicate, and finally finish the Lego set together by teamworking. According to the Play Included introduction of this project, so this project is designed to help the participants, especially those children, to develop their social and emotional skills in a fun and inclusive environment. Which leads to our project, the Project Hybrix. So what is a Project Hybrix? Project Hybrix is an exploratory project that's trying to recreate the experience of the brick-by-brick program in a remote setting. The users will be able to build the same Lego set with both virtual and physical Lego pieces. And the Hybrix will be a solution that allows the users to experience the real brick-by-brick program from anywhere at any time. Now I'm going to invite Iris and Amelia to introduce our user experience.
So there are 2 groups of our target users. One is the trained adult, who might be the educators or the school faculties. And another group is the youth, who might be aged between 9 to 13 years old. So this is a one-on-one section between a child and an adult, and the child is going to build a physical Lego, and they need a tablet to connect with the adult. And the adult is actually building virtual Lego on the tablet. And they're going to build different Lego items that belongs to the same scene. And in the end, we are going to use AR to combine those different Lego items as the whole scene. And during the game, there will be two roles. One is the builder, who is actually building the Lego, and another is the guider, who has the instruction map to guide the builder for the next step. And they are going to switch roles during the whole game. So right now, I'm going to introduce the flow when the child is the builder and the adult is the guider. So we can see that on the tablet, that the adult can see the exact same scene that the child can see. And on the right top of the tablet, the adult can see the instruction map of how this section of Lego looks like and what the next bricks they need to find. And based on the instruction map, the adult can just describe how the next brick looks like for the adult to find it, for the child to find it. After the child has found the right brick, the adult can guide the child to place the Lego brick with the right position and angle. And the adult can also use their fingers to draw signs or double-click for highlights. And the child can see the exact same signs on their tablet. And after the child has finished build this step, the adult can just click down for the next round of the instruction map. And when it is time, the adult can decide and communicate with the child to switch the role. And the adult just need to tap the switch role button. And right now, there will be a page showing the time countdown on both of their tablets. And after this page, the child will be the guider and the adult will be the builder. And this part will be introduced by Iris.
Yeah, so when the adult is the builder and the child is the guider, they will be seeing the same virtual scene, which is the virtual set of the Lego the adult is going to build. And then here I'm using the current prototype we built as the background. So the first thing the child needs to do is to check the part the adult is going to build. So they can click on the top right, the little part, and they can see a 360 view of the part. They can always rotate to see more details and different angles of the part. And then the child needs to know which bricks they are going to find for this part. So they can go to the little brick underneath and click on it again to check the details. And once the child knows what brick they are going to find, what they can do is to go to the brick piles. They can click on it, which will take them to see all the bricks available. And then they can start to select the bricks. And once they think they got the right bricks, they can just click Found. And now we are switching to the adult's perspective. Once the child clicks Found, the adult will see the bricks dropping on the table. So there will be a little animation here. And then based on the child's verbal instructions, the adult should be able to rotate and manipulate the bricks and put them in the right positions and angles. And then once they're both confident with the part, they can just click down, which will lead to two different scenarios. So if they got it right, they'll be able to proceed to build the next part. If they got it wrong, the adult can always manipulate under the child's instruction until they got this part right. And now I will hand over to Ethan to talk about more perspectives from the technical side.
Thank you. So we identified two major design and technical challenges for this project. The first challenge is making players feel like they're building the same thing even though they're not touching the same set of bricks. The second challenge is facilitating the same means of communications the players would have in a physical setting but remotely in different places. Let's first talk about the first challenge. One of the requirements for this project is that the child must be building physical bricks. This feels great to play with, but presents challenge for remote play. If you're not in the same room, obviously you can't build the same brick together. And if you're building two different sets in two different places, then it doesn't really feel like you're building the same thing together anymore. To address this problem, we decided to implement a digital bricks building system for the adult. This has two benefits. First, building a digital set is more interactive and interesting for the child. They will have the opportunity to supply bricks and have an easier time giving instructions by moving the camera around. And second, this gives us a creative solution to reinforce the idea that the players are building something together. After the two players had completed their respective pieces, the child will have the opportunity to put them together in one set piece using augmented reality on the tablet. The scene will have interactive and animated components such as swimming fish, bubbles, and seaweed, creating a sense of wonder and accomplishment. More importantly, this climatic moment reinforces the ideas that the two players were building towards the same goal all along. To facilitate this moment, we first developed an asset pipeline to import accurate brick models into our project. This consistency between physical and digital bricks is crucial for the coming together moment to ensure everything looks in line with each other and that everything looks like they're in harmony. Next, Steven will talk about our second challenge.
So our second challenge is about personal connections. And here, so firstly, we need a voice to give instructions. And secondly, we need eye contact when there's a child, which is important. So many people would ask, why not using Zoom? And our solution is we're actually using it. So Zoom is great for video calls, and it's not necessary for us to develop a similar function. So here's how we're going to use it. We set up a Zoom meeting first, and then open our hybrid project, and then drag the Zoom window to top left corner, and that's it. And besides Zoom is only for face and voice, we need body language when we are in person. So we decide to have touch gestures. Both child and adult can point on the screen to give instructions, like here's the brick or here's what the next step is. Since they're seeing the same thing, they would have the feeling that they are pointing in front of each other. In other words, they are better connected with this feature. And next, Olivia will be talking about our testing.
Thank you. I'll talk about our testings and iterations so far. So we have done 2 play tests so far, and for our next play test, we plan to have both a child and a trained adult try the demo. This will help us understand how experienced facilitators interact with the system and how we could better support both children and adults in guiding the Lego building process. Our first playtest was with a 13-year-old child, June. I conducted the playtest through Zoom, asking him to build Legos only relying on my verbal guidance. At first, I expected the remote building to be frustrating for him, but surprisingly, he actually didn't find it too difficult. He thought that it was quite similar to real-life Lego building, and he really enjoyed watching the virtual Legos. He found it really satisfying, and said he enjoyed the experience, feeling like he was getting the best out of both worlds, playing with real Lego when he was building and playing video games when I was building. Our second playtest was at ETC Playtest Night, where 7 participants tried out our demo. This allowed us to observe how people interacted with the system in person, giving us more detailed feedback on both usability and interaction. Across both playtests, the biggest takeaway was that people really enjoyed the cooperative aspect of building, and they thought it was fun and satisfying. That being said, we also received an important feedback on areas that need improvement, both in terms of gameplay and technical issues. A key area of improvement was mostly on tech side, including the camera movement, brick rotation, and placement. And also we got some feedbacks of adding some features of undo, redo, and auto brick sorting by color or types. So for our future implements, we will adjust the camera sensitivity and ensure the view centers on the piece being worked on. To improve brick rotation, we will implement gestures or buttons for easier control, and we will adjust the distance of floating bricks to prevent them from obstructing the view due to hand placements. And the hint and highlight system was already planned before playtesting, and it's currently in development. Some feedbacks suggesting adding an undo or redo system for auto-sorting bricks by color or type. While these features would make the game easier, we want to preserve the challenge of making and correcting mistakes, just like in physical Lego building. These changes wouldn't align with our goal of replicating the real-life Lego building experience, so we ultimately decided against these features. For the environment art, since we chose to use a turtle and a dolphin Lego set for this demo, we will create an underwater themed environment for the background when building Lego virtually, as well as for the final coming together moment. And I'll hand it back to Max.
Thank you, Olivia. So I've listed some of the project milestones that we are going to achieve during the whole semester. So before the Halves, we have already done the pre-production stage, also meet with Carl for some feedbacks, and also we have attended our first official test, which is the ETC playtest night we just introduced. And before the Halves and in the next half of the semester, we are going to demonstrate our project to Dr. Gina's team from Play Included this Friday. Actually, in fact, Dr. Gina is one of the founder, also one of the primary designer of the Brick by Brick Club and Play Included, and she will be visiting Pittsburgh from Cambridge, UK, at tomorrow and Friday. So we are going to demonstrate our project to her, and also we are going to prototype testing our project by attending the ETC Playtest Day, which has happened on March 29th, and also make the final adjustments before the soft opening. Hybrid is not just a project, it's the first step of connecting the Brick by Brick program with entertainment technology. By bridging the virtual and physical world together, we are making the Brick by Brick program more accessible than ever. This is the presentation this is our presentation, and now we are open for feedbacks and questions.
Any questions?
So it feels like the value, the most powerful part of this is the conversation between the parent and the kid. Is that part in your design, or is that just something that happens organic and on the other side of the screen?
I can answer this question. So yes, the communication between the child and adult is definitely like probably the most important factor in this experience. We know the adult is like a trained facilitator, so they will be responsible for like actually having those conversations. For our project, we are just trying to ensure that whatever conversation they're having with a child in a physical setting, they can do the same thing in a remote setting.
So I have full confidence in y'all that y'all can build a tool for this relatively narrow set of experiences that Brick by Brick wants you to work on. I'm wondering if you see potential broader uses for it or ways that you can more fully express your creative ideas about experience design and things like that within the bounds of the project?
We believe that in the interest of scope, we have made the system of brick building somewhat restricted. While we can still make mistakes, the game will still only have like a fixed set of instructions that you have to progress through, as that is part of the Brick by Brick program, and we're trying to replicate it. But I think outside of the project scope, if we have time and if this is interesting, perhaps in a future semester or by some other team, we'll be able to build upon the system and have it be able to support free play. But this is not within our project scope at the moment.
And also, because we are using the virtual worlds, a virtual platform for this project, so at the very end of semester, if we still have time, so we are going to add some like the ambience, animations, and also those kind of little, probably virtual effects made with Lego style, and those other kind of stuff that you might never see in the real world. That's also the part that we are planning to just make the virtual world looks kind of beyond the real life. Oh yeah, and the other thing we would like to mention is the way that we convert those Lego models to the let's go back to that page. Yeah, the way actually we have already created a pipeline ourselves just by convert the Lego pieces from software. Actually, it's a library called the Studios to Blender, and to like it's not only Blender, also to all the engines that convert them to the more general format. So yeah, we have already created a pipeline for that, and I think it's also available for
Alice. Yes, Project Alice also uses Collada model format. So if the Alice teams would be interested, they would be able to very easily use the same process to port Lego pieces into their into the engine for whatever they may desire. Just a fun fact.
Time for one more. Okay, thank you, team. Now we take a break. So let's gather back here and start promptly at 4:30, okay? No, we got time. guys are all ready, right? Yes. Okay. All right, if people can take their seats, we're about to get ready. You're all recharged. This is good.
Perfect.
Yes. So just a quick show of hands. Who likes to have a break in the middle of 8 presentations in a row? All right, it carries the day. I kind of figured. Okay, you guys ready?
Yes.
Okay, I think we got most of our crowd here.
Yes.
Thank you.
Okay, are we good? Good. Nice. All right. So, welcome to our Halves presentation. We're Team PPP, and we're making a virtual pet with aspects of physical presence. My name is Brian. I'm the software and hardware engineer of the team.
I'm Jerry. I'm the technical designer.
I'm Paige. I'm technical artist.
I'm Sophie. I'm the rigging artist, animator, and associate producer of this team.
I'm Joy. I'm 3D character artist and also a tactile designer.
And I'm William, the producer and the sound engineer. And our faculty advisor is Derek Ham. So, our goal here is to make a XR companion that leverages the physical aspects of the bonding process in order to foster a deeper relationship with the user. When it comes to physical interactions between humans and animals, touch serves a very important role. It communicates the intention of 2 different species that shares no common language, yet at the same time establishes a mutual understanding that transcends the need for words. There are many forms of companionships available on the market, each facilitating bonds via a different mean. But Vue has managed to leverage all aspects of the bonding process with zero compromises. Our virtual pet aims to bridge the physical intimacy with the background presence of our predecessors, all in conjunction on top of the platform that is the digital platform of virtual pets.
Now let's do a demo video of how our pet works. Okay, I'll do like an improv in the physical world. So basically, you have to put your pet on a little base we designed. And as you put it, you will see its virtual presence emerge from its body. You can touch its head, touch its back, and finally touch its tail. You'll see different animation and audio feedback showing its satisfaction being touched. And as you pet it, you're also charging a dream energy to your pet. And as you charge enough, your pet will eventually come out of your physical body. And then you can do more interaction with it in the virtual world. So that's our demonstration.
So who is this pet for? We're targeting mixed reality headset users of all ages. We expect that MR headsets will be more accessible, affordable, and more widespread in the future. And people of every age demographic will have their own reason for wanting a tactile companion as they work or play in the device. Success for our project is defined by narrative of our experience, by its interactivity, and the functionality of our tech. And our final deliverable will be Lucille, the pet you just saw, ready to be adopted by headset users, offering 3 to 5 minutes of physical and virtual interaction. So now we'll recap what we've done so far to achieve these goals.
Let's talk a little bit about game design. So as you see, we're not making one pet, but 2 pets, a virtual pet and a physical pet. A question naturally arises for us is, how are we going to deal with the relationship between the 2 pets? Our team strategy is, we want to use the physical pet as a weird controller that takes your touch as input, and we want the virtual pet to create the fantasy as the audio-visual feedback. And to differentiate from other virtual pet apps from the market, which only has virtual interactions, we want to make touching an important part of our interaction. Our holy grail is this virtual and physical pet are one thing. So essentially, when you hold it in your hand, you only see the virtual pet, but you can feel the physical pet. That is to say, however, our holy grail is hard to reach, because tracking the object is so hard on Apple Vision Pro, no matter on computer vision based or using vibe trackers, which is not supported. So we have to separate these 2 bodies, the virtual and physical bodies. Then, how are we going to deal with their relationship in this situation? We design a narrative. So right now, you are hacking into the dream of your pet. That explains why this physical pet is always passive, because it's sleeping. And it also explains why the virtual pet is separated from the physical body, because it's navigating freely in its dream world. However, we didn't completely give up on the idea of overlaying the 2 pets. So we designed this little ritual at the start of the game, which is showing in our demo video just now. During this ritual, the user have to pet a pet, and they will see that virtual pet lies inside of its physical body. And it will eventually jump out from its body to enable more virtual interactions. We want this little ritual to make player believe that this virtual and physical body are strongly connected. Also, speaking of touch, we make touch important by give tons of animation feedback to touch based on different location, different situation you're touching the pet, which we'll cover later in our animation part. And also we design a mechanic called energy flow. Essentially, any interaction you did with your pet in the virtual world consumes its dream energy. That can only be refueled by touching it. Let me see an example. It's like when you put on the glasses, a headset, you're interacting with your pet, like doing the little gesture to call it over. Your pet will become happy, but at the same time, your pet's dream energy will be consumed. And as the dream energy drops, this body will gradually fade out. So right now, what you should do is to touch its physical body again, charge it, and make it reactive. This strategy ensures touching always involves in every loop of interaction we design for the pet. Now let's talk about our art.
Thank you, Jerry. So for our art, for the physical plush, our physical pet is always be in a sleeping mode, and we printed out it so we can vision the size better, which we'll hands around if anyone wants to feel of it. Just keep in mind that this is not the actual final physical plush, it's just to help us size of the proportion of a pet. And for the tactile design, we have the hardware embedded inside our pad, which will be surrounded with a hard foam that feels similar when you pet on it. It feels similar to when you're petting on an actual animal flesh. And inside of the core, we have 3 different sensors that can sense force on it, and it will be placed on top of the head, the back, and tail to read interaction from our audience. And outside of the core, we will have a removable furry skin. And for the fur that we want, we did a couple research and survey that we'll hand out now for the audience to touch. And we have our winner, which have the perfect length of the fur and also the softness. And for the actual physical body, we have implemented and we have developed a lot, the versions from version 1 to version 3 from a blobby shape to more specific shape of our pad. And we also created a template pattern for future production use. And for our character, we want our character to feel unique, but also still have the familiarity for our guests. So we created this character. It's like a mixture of seal, but also have a hint of cat and dogs. We didn't make like a very existing animal, like for example cat, because we don't want any direct expectation or assumption when our guests interact with our pet. So the whole experience for our guests is personal and it's very new, so there will be no potential expectation.
And now let's talk about rigging and animation. We use Blender for rigging, utilize Shape Key to animate the eyelid, ensuring smooth and natural movements. A significant amount of Lucio's feedback comes from animation, making it a key focus for iteration. For now, we have 22 animation clips, and we are making more in the future. To improve the coordination within our team, we created an animation production form that tracks the file name, frame range, and progress status. Additionally, to ensure smoother handoff, we create a diagram that shows how the animation system works. Also, a short video that includes the animation overview. So at the beginning, Lucio is asleep. If you interact with its physical bodies, head, back, or tail, it will trigger different feedback animation. After several interactions, Lucio will wake up. Once awake, Lucio has different animation. As Jerry mentioned before, Lucio has this low energy mode that will be triggered when it's not being touched for a long time. And this low energy mode shows like Lucio is falling asleep. And you can wake it by touch it. And also, Lucio has animation that invite petting on different parts. When you pet it, it responds differently depending on the area you touch.
When it comes to rendering, things get a little bit tricky, since we're a project that utilizes polyspatial for an XR environment, which means we are always in pass-through mode. Most of rendering components are not supported. And it also takes a lot of time to figure out what is possible and what is not. For example, multi-pass rendering, code-based shader, visual effects graph are not supported. Even the built-in particle system is only partially supported. We're still actively seeking for workarounds for multi-pass rendering because we want to develop the fur. With this limitation, let's see what we have accomplished so far. The first thing is this eye shader. The eyeball is just a single sphere-like mesh, and I started from unlit empty shader. It adds up features like pupil, cornea, iris, outer ring, and 2 highlights can be adjusted. It will reflect the light reflection and also can be manually adjust its position. All of the different parts can be changed in size and color. And it's all mathematically computed, so you don't have to have any texture mask. And another tricky one is this low energy transparent mode. As shown in this picture, the first 2 are URP transparent materials. You can clearly see the internal structure like T's eyeball. It's pretty scary. We don't want that. However, the traditional way to do it is to add another pass to render. But remember, multi-pass not supported. So here is our implementation over here. It's actually an opaque shader. And we use screen position times dithering factor to achieve this transparency mode. We perfectly tested it with Apple Vision Pro, although in the demo video we just showed, the noisy one is just the problem with the screen recording. 2 cameras has different resolution. For the hand detection, we won't have this subtle energy flow effect shown over here. For the body materials, this is the current look, but more details are coming as more texture, patterns, and possibly the fur. Here are also some visual effects we made for illustration for design and emotion, like charging, happy, sleepy, sweat, or some like spoon effect.
To make our pet Lucille sound effects, we took on its character, and Sophie and I actually voice acted and recorded the sounds. So that's a sleeping sound. And this is like an affirmation happy sound as examples.
Yes. Whoops, sorry. All right, so how does our tech help us solve our problems? The way we're actually communicating telemetry from the stuffed animal is kind of interesting. Instead of dealing with a nightmare of figuring out how Apple handles Bluetooth communication from the middle of the surface, we saved a lot of time by simply making a microcontroller that emulates/mimics a Bluetooth keyboard. As the sensor reads values that changes from pressure levels 1, 2, and 3, the keyboard, quote unquote, will output key codes Q, W, E respectively, essentially allowing us the entire array of the keyboard keystrokes to use encode for inputs. Although there were some slight complications, we made some tweaks and ultimately settled on a Xbox game controller instead, with very little issue. Where is it? And finally, we slap a battery on top of it. Our device is basically now configured to communicate physical interactions to the Apple Vision Pro. And details regarding this entire software and hardware setup is documented with the intention that if I get hit by a bus tomorrow morning, my unfortunate replacement will have all the information needed to replicate this thing one-to-one.
So where will we go from here? Now that we have a prototype built up, we want to expand features and make it so that we achieve our goal of a tactile XR pet you can build a relationship with. So primarily we'll focus on adding new touch and virtual interactions, and we'll make ways to make it personal. So you can customize it and make your Lucille your own.
Yeah, so we want to provide this avatar system. Currently, the body shader and the eye shader can already change the color. We want to polish this feature and provide some presets, which is nice looking. And here is also a picture to help illustrate our idea.
Mm-hmm. And lastly, we'd also like to explore a more integrated method of weaving our electronics into the fabric. With the exact same circuitry setup, we can essentially replace our variable resistors that you saw earlier with homemade ones that are crafted from copper sheets and conductive threads. This would enable us to camouflage the electronics further away from the user, while also allowing for more diverse interactions such as scratching, pulling, and stroking. And in fact, all the prototypes you see right here has already embedded electronics within it, so it should work.
All right, and things move very fast after Halves, so we'll be iterating on new circuitry, new shaders, customizations, and our pattern designer or tactile designer will be pattern making so that the plush is ready for playtest day. The full plush should be done by week 11, and the rest of us will finish work before softs, after which we'll just do bug fixes and get ready for finals.
Lastly, a massive thanks to our project consultants, Olivia Robinson, who informed us on the issues of working with electronics embedded within soft tech, Jesse Schell, who gave us some foresight on designing around experimental XR interactions, and Dave Perda, who advised us on soldering techniques and various noise signal shielding techniques. And that's a summary of our Halves presentation. Thank you, and we'll take any questions now.
Any question?
So the first thing I did when you handed me the 3D printed thing was to just like try to play with it, like see what the balance of it was, move it around in my hand, put it on different surfaces, see if it stood up or rolled over, that kind of stuff. Have you done that kind of just like basic user research to see what people want to try to do with this thing, even in the form that you have it now without everything integrated together?
Jerry, you can cut me off anytime you want. But yes, in fact, that's one of the biggest purpose we want. Like the reason we got the 3D print first, because we know it's going to take some time to get the soft tech ready. We 3D printed something just to kind of play among ourselves and play around some of the people, friends that we know, some of our classmates too, to kind of get a reaction on how they'll handle the actual object itself. And Yeah, our findings are pretty interesting. Like, despite it being like a very hard surface, we still somehow find that people instinctively start stroking it. Like, from this, even this is a surface, like we didn't put any kind of soft texture and people just start stroking it. That seems to be, we interpret it as the fact that the pet-shaped nature and the way that they kind of cradle. And actually, that's another thing. They cradle. A lot of people, when they hold on to the instinctive thing is almost, I don't know, it's like just parental instincts, but they cradle it like a baby. So there's a couple of findings we found with regards to how people instinctively handle it. But we kind of have to take that with the greater context of how the final plush with all the different kind of textures and the fact that you can squeeze it might different, the way they might interact with it. And also a final plush is frankly a little bit bigger.
Maybe a related question. Are you more focused on the entire experience with the physical object as well as the virtual experience, or are you trying to focus more on the virtual experience for the second half of the semester?
I think for our project, we are focusing definitely on the physical input first, because there are so many more depths into that input, like scratching, do something else. We want to explore that part as our priority. Definitely, we will include more virtual interactions, but I would say I will make sure that every one of them is connected to touch, just like our energy flow mechanics. Yes.
Plus, given the time and Jerry also at one point thought about using the microphone too, such as you can speak it or somehow call to it. But priority is physical. Then we'll add on, if we have time, audio and more virtual interactions too. Mm-hmm.
Are you working with children at all?
Go back a bit. I know the preconception that when you think of... do you want to answer? Okay. I know the preconception when it comes to stuffed animal, you immediately think, oh, stuffed animal, children's play with them. Unabashedly, I have 3 of them laying on my couch that I play with it all the time. I know... Sorry, that might not answer your question. But
it sounds like the answer is no. Is that the answer?
Yes, I think that's the most direct answer would be no. But children isn't our focus. Isn't just children.
Okay. I would encourage you to talk to children. They have special insights about stuffed animals that adults don't have.
That sounds cool.
We'll get some. I think we did sign up for. You did clearance now already, did you?
I did.
Okay, thank God. All right, so we'll be able to get some information from children.
So you're doing experiments now or further development with potential for soft circuits. Are those purely as input? I couldn't tell if you were actually thinking about having some output on the soft creature itself.
So yes, output. That is a bit tricky. Given the current setup we have. We're currently emulating an Xbox controller, and technically speaking. As with anything when it comes to Apple, technically speaking, we could get Unity to communicate to Apple Vision's operating system and have that pass that information. Oh, whoops, sorry. Pass that output information, and we interpret it on my side with an embedded system, and have it emit some sort of motor or some sort of vibration, that kind of thing. Technically, but the reason why we had to switch to Xbox controller in the first place is because Apple doesn't do the things that we want them to do. The keyboard should have worked. But it doesn't, because for some unforeseen reason, Unity applications on the Apple Vision Pro doesn't interpret keystrokes as inputs, so we had to use Xbox controller. So theoretically, yes, we would like to do that. Technically, we don't know if it's possible.
How attached are you to the design of this character, and in particular, the tail? Because I feel like the tail is a missed opportunity in terms of animated performance or connection with your guest, right? To communicate happiness or wag a tail like a pet might.
So for character design, especially for the tail, I wouldn't say it's for the technical side of animating, but the reason why we all landed on a tail is because when we are still at the first stage of designing the pet, we have 4 legs and a tail, and we feel like the tail is kind of a way to communicate like how dogs wag their tails. And we feel that also like creating a ununique creature, like no one's have a seal in their home, right? So having a very unique creature, like experience of like seeing how a two-leg and also like a tail, how those animals speaks to you, and that's kind of like different from
Right. My point is because it's a fish tail, that doesn't communicate because that's not how fish communicate. So maybe just consider that.
So maybe we can like assign a session with you to discuss more about how we can better communicate that in animation part.
Awesome.
Any other question?
Awesome. All right.
Okay.
Thank you so much for
Thank
time.
you.
Hi, we're Holocraft Studio. We're a team that's dedicated to deliver a miniature-driven virtual production short film, and this is our Halves presentation. I am Victor Zhou, the co-producer for the team.
Hi, I'm Percy. I'm the 2D artist and also in charge of painting the miniatures in our project.
I'm Jesse, the 3D environment artist.
I'm Jimmy. I'm the programmer and technical artist.
Hello, I'm Lia Shi, and I'm a co-producer and tech artist.
Hi, I'm Boris. I'm the UE programmer, and I'm in charge of the motion capture pipeline.
John is our amazing instructor who has always been providing us invaluable advices. And also we got two SMEs who are Matthew and Andrew, who always give us great feedbacks and opinions from the perspective of an industry expert. So now we're giving a quick overview of our project, which first we're going to deliver a 2-minute miniature-driven virtual production short film with a documentation of the production process, which also includes a documentation video. And who's our target audiences? They are aspired filmmakers with limited budget, and also we're trying to prove to all the industry professionals that we got certain skill sets it requires to complete a virtual production pipeline. And there are some keywords to our project, which is real-time mocap, miniature-driven virtual production, and also we're using real-time interactive lighting in order to create that sense of immersiveness. And Leah is going to talk about how we're trying to accomplish certain technical achievements with a series of shots.
Okay, thank you. So as you can see from left to right, we are first going to capture the terrain and physical miniatures. So our miniatures gonna be like buildings. Then we're going to take some close-up shots to show how our physical sets are going to blend seamlessly with the virtual background, which will be shown in the TV screen behind the miniatures. And as you can see, once the environment is established, which is a town, and our main character, this rocky giant, will played by a mocap actor in the real time, and it is formed by rock. And once it's finished the forming process, it will start to destroy the town. And our scene will end up with a physical cannon miniature that fires at the giant. And in the virtual world, the giant will react to the hit and die. Yeah. So why we are choosing these shots? Because those shots are designed to highlight our virtual production skills. So we want to showcase that we're capable of blend the two worlds, not only through from virtual to physical, like through dynamic lighting, but also we're able to make transition from physical to virtual by doing like the canyon example we just mentioned. And here's a video we want to show you about like a detail. This video is a heads up of the technical details we're going to talk about later. So classes of destruction, that's our project title. And first, here is our studio setup. We have the miniatures on the table, and the big screen shows our virtual world created in UE. And we have the 3D printed miniature samples, and those are purchased ones and painted by Percy later. Yeah, and for the giant, we're doing in real-time motion capture. Here you can see we're able to do a markless. And dynamic lighting is also important. We're able to adjust the light through the app in our phone. And you can see we're able to match the light tune within the virtual world. Yeah, and lastly, we want to show you like an in-camera shot, like just to give you a sense how our final deliverable going to be looks like. Yeah, and I will hand the mic to Victor.
Yeah, and in order to justify where we are making a miniature-driven virtual production, first of all, we'll have to do a briefly introduction of what the virtual production is. So in short, virtual production is all about blending the virtual world and the physical world. It's about blurring the boundary between reality and illusion. And normally, how do we do that? We build a virtual environment within Unreal Engine, and we'll present it in a large volume LED screen, which we'll be placing behind of physical actors and physical props, and with camera, we are capturing all that to create that sense of unification and harmony. And how is virtual production different from traditional film pipeline? For traditional film pipeline, is a relatively more linear process, which makes it harder to do a change, because you can't really see how everything comes together until the very end of the process. So in order to make some changes, it's very time-consuming and very costly. On the other hand, for the virtual production pipeline, it's more of an iterative process, which makes it easier to do that, the changes to go back. So it's a cycle. It is easier for you to make changes and cost you less money and less time. And what do we apply to the traditional virtual production pipeline is that we're on the asset creation process, we're implementing our physical miniature set, and we're also using mocap avatar acting into the live action session. And also, we're trying to create that sense of immersiveness through the dynamic lighting system. And here are some industry examples of how they utilize miniatures and virtual production. So, as you can see, normally it's been used in films, TVs, and advertisements. But why are we choosing miniature? Why is it miniature-driven? So, by the name, you can tell, like, miniature, it is mini, it is tiny, it is small. So, it kind of gives us a unique advantages comparing to some large volume virtual production studios. First of all, it can easily create that noticeable scale differences, which enhance the sense of depth and realism to our shots. And also, it takes less workload. It is scene set adjustment. It is necessary for a VP to have easily movable scene sets to serve iteration purpose. And by doing that with miniatures, it helps us do that easier and like take us way less money. And also, in order to operate that virtual production studio, this scale, this size of sets also allow you to just use a much smaller crew in order to do that. And since now we're talking about studio setup, Jimmy is going to elaborate more.
Okay, thank you, Victor. So this is the setup diagram of our studio. It is mainly divided into miniature area, workspace, and motion capture area. The virtual background is provided by a large screen with two smaller ones supplying the ambient lighting. Additionally, we use 3 physical lights to serve as the main and supplementary light sources. For camera tracking, we use an additional iPhone as a sensor to transmit the data of rotation and location to Unreal Engine. And then we process the data in Blueprint by applying the scalings and offset before the final image on the screens. In terms of dynamic lighting, the virtual lighting is controlled by a keyboard to adjust the skybox and scenes lights. For physical lighting, pre-recorded actions are played back and controlled by a mobile device. This is our current demonstration of the achieved effects. The reasons why we picked the red colors is because after multiple tests, we find that these colors suit our physical set best and make it easier for us to integrate the physical and virtual environment. In the next part, Boreas will introduce the technique of mocap.
So we choose to use a Merciless mocap solution called Dollars mocap. It is accurate in dark environment, and it is affordable, and it is convenient to iterate. And this page shows our workflow of the motion capture pipeline. So first, we use the Orbic depth camera to capture the live acting of the actor, and then the Dollars mocap software will automatically analyze the motion and export the motion data. Then we transfer the motion data to UE Mannequin, and we use the accurate targeter to transfer the motion data to our customized model and skeleton. We've also done some extra work that allows us to use some non-UE standard skeletal model, for example, some MMD or VRM skeleton to share the motion data and to share the motion capture software.
So this is a preview for the virtual environment inside Unreal Engine. We chose this crimson color theme and the blood moon for an apocalyptic background, and it also fits into the grimdark art style from physical model sets. For the digital character, we created this rock giant with hard surface features to avoid weight painting issues. For the environment part, we chose to make this gray and dusty texture true to real model paint inside the real grimdark paint style. And the architectures are all composed by modularized pieces to allow more possibilities in construction type with limited amounts of assets. For the floor grid, we optimized them by projecting high poly models onto a low poly mesh. With all the model details are implemented by texture maps so that we could get better performance while running in lower mesh count budget.
Okay, so now I'm going to talk about our physical sets. So in our project, our decision is to use pre-purchased plastic kit combined with 3D printed resin kits. And the reason we use pre-purchased plastic kit is because it sets a scale for our project and let us know how big our model should be. And also, as you can see here are the reference pictures. We used the terrain from Warhammer 40K, the Kill Team terrain. It will demonstrate clearly to our environmental artists how the scene and the building should have a style. And also, this plastic kit is much more easier to customize than the resin kits. So we can like shape it whatever we want, and also we can change its size. And here are the painted thing I have done recently. Also, we have tested how it looks in our light settings. We can still distinguish between the brick texture and the metallic parts. And because of the red light, I have abandoned the red color of red in actually painting it because it will be blurry and it can't be seen if in the red light. And here are the successfully tested 3D printed model. We are also going to be using this printed resin buildings in our project later.
And this is a rough schedule of what we're going to do next. So in the next few weeks, we're trying to accomplish and complete all the physical setups and finalizing all the virtual assets. And then we'll entering the stage of principal foaming, which will help us figure out is there anything that need to be tweaked? And then we can do it in the post-production. And even if after that, there's still something that needs to be fixed or tweaked, we'll then using this cycle of virtual production and then going back to do some more shots and then post-edit it again. And then we'll do the finalization and delivery. We're Holocraft Studio. We're a team that's dedicating to deliver a miniature-driven virtual production. And we're now opening for questions and feedbacks. Thank you.
I noticed you guys are using the red light. I had a question about that and the detail in the paint job. It seemed like you had some really nice colors and detail in the virtual and the painted texture, but when you put the red light on, everything just went red. What type of red light are you using, and do you plan to try and adjust it to bring back some of the other colors that you guys have in there? And how does that tie into the pipeline realities that you guys are discovering?
Okay. So the reason why we're choosing this kind of red light, it's because during several tests of our inner testing, during the shots, we found out that with the limited studio space that we have, red light seems to work the best, even though it kind of get in the way of how our miniature set is getting painted. But we believe that with the right painting materials, it can still show the kind of texture we're hoping for. Because from the example we're showing in the presentation, it's just it's a version we'll keep tweaking about. So there'll still be some adjustment to it. But overall, the red light, it's a choose because of style, and also it kind of fits into the narrative setting of our story, which is a cursed town that's being attacked by a giant rock golem. So we feel like that's the best choice for the lighting tone. Yeah, thank you.
I think what you're doing is interesting. I struggle to understand where you think this technique really shines. You're putting together a short film, you're getting your sets and your models together. Can you give me an example of a shot where you feel like, can you describe a kind of shot where you feel like, wow, this is where this technique really shows its value, that this is really worth doing, as opposed to, compared to other ways you could do the same kind of shot?
I want to clarify, is it about how we combine those two, miniatures and virtual together? Because there are some some advantages comparing to just virtual production and just miniature itself, or is it?
Yeah, I mean, and maybe I misunderstand. I feel like your premise is that combining these two that seems to be the center of what you're aspiring to. Can you give me an example of a shot that combines miniatures and the virtual production that really feels like, yeah, this is going to be good value, as opposed to doing it all virtual or in some other way?
So in this shot, we actually this is how we're trying to accomplish some interactivity with the miniature set, because like as you can see in this picture, is like sort of like you can build a very, very large scale sets with just miniature itself, but also you can try to interact with how how we're presenting the virtual environment. And with this kind of set, like what it sets it apart is that normally when you're trying to just build a miniature set, you're doing it with like green screen. So it is harder for you to use like dynamic lighting and some like puppetry interaction with the green screen. Like it's harder for you to do post editing. So we kind of feel like if you're using virtual production and miniatures together, it sort of solved the problem and like what they cannot really do in this kind of pipeline. Does that answer to the question?
I think I understand. Yeah. I'm definitely going to encourage you as you move through the semester, finding a way to really show that value. I think is going to help people understand like you know where the real value is in this technique.
Okay.
Just to add to Jesse's question, I want to know, how will you know if you succeed? What are the metrics that you'll say, yeah, this is it?
Okay, so throughout the process of our creation, we'll keep communicating with our SMEs who are experts from Disguise, which is also a virtual production pipeline, virtual production company that's like been building this for a while. And from the current feedback, they're like giving very high feedbacks on what we're trying to accomplish, and they said it has a high value of what we're trying to accomplish here, because normally it is very time consuming and like it'll cost you a lot of money to set up this kind of like virtual production set if we were to use some like physical sets. So if we somehow manage to make the video looks real, it looks decent, create that sense of immersiveness, then we're like proving that it is really useful to build up a miniature set with this kind of volume, which is like smaller and like way more budget efficient. Yeah. Oh,
Thank you.
Hello everyone, we're Team Lost Echoes. So here's our team. And thanks to our instructor Brenda and also our consultant Jonathan. So our game is a music-driven puzzle game inspired by Chinese folk music, especially Nanzhao Fengsheng music. So our purpose is to build an interaction environment to kind of raise people's interest of learning music. And also we want to introduce a new method of teachers that incorporate in class to kind of teach younger kids to learn music. So our target audience would be casual gamers and puzzle enthusiasts from age 13 to 40. And also for educators and students that are introduction to cultural and music contest. So our project has 4 major components. The most important component is music and puzzle. Our music is based on the real Nanzhao Fengsheng music, which used the pentatonic models for the music. And also we have interactive environment puzzles to kind of guide people throughout the whole story. And as a plus, we have storytelling, which is based on real history stories, and also art that uses reference from the ancient Chinese building. So here's our demo video.
So we've researched a variety of games that shares a similar value, gameplay, and art style with us. For example, from Chants of Sonar, we've learned how to use environment puzzles to teach a new language. And from Wandersong, we've been inspired by how players can use music to interact and impact the game world. Our game has 4 key features: top-down environment exploration, music-driven puzzle solving, learning, and communicating with music. This scene is our prototype of our top-down template. Our players can move freely in the scene. And we have introduced 2.5D puzzle games for our puzzle solving part. 2.5D means 2D characters and objects with 3D collisions implemented in 3D scenes, but looks like 2D due to the camera settings, just like the style of Don't Starve. Players can use 5-element melodies to interact with the game objects. For example, the player used fire melody to lit a fire and drop the walls away here. By solving the puzzles, players can get important items or learn new words that are crucial to the following missions. In our main level, our player can communicate with NPCs with music languages. Each NPC has a specific vocabulary due to their occupations and backgrounds. Only when the player is talking about things that the NPC is familiar with, they will react, and player can gather some new information from them. We also introduce a notebook to let player query things that they've already learned. Once the player reveals something new, it will review in the notebook, just like this. Please aware that the 5 elemental notes and 5 elemental melodies are different things. If we take notes as letters, then we can take melodies as spells that are made up of letters. These spells are only used in the 2.5D puzzle solving part to our interaction. Meanwhile, in the main level, we have a notebook of music dictionary of meaningful words. Players can use these words to communicate with NPCs in main level and push forward the quest lines.
So here comes our story. Our major character is born in Nanzhao Kingdom, which is in Tang Dynasty and nowadays Yunnan, the southern part of China. So he is a mute magician. That means he cannot speak. So through the settings, we encourage the players to interact with environments through playing flute, and also he can talk with NPCs through music. So our history background is based on Nanzhao Fengsheng music. So at that period of time, the emperor of Nanzhao wanted to rebuild the connection with Tang Dynasty to stop the war. So the player will re-experience the whole journey in this game. So we have divided our game into different levels. The first one is travel among people, and then collect musical instruments, and then recruit musicians, and also form the ensemble, and finally perform the music in the capital city of Tang Dynasty. So due to the time limit, in this semester, we'll only focus on the first 2 levels, which is travel among people and collect musical instruments.
So to imagine our game in a whole picture, we are going to have all these elements and levels in order to build a complete storytelling and music experience. However, since it's our vertical slice, we are focusing on to teach the player the basic notes of using the flute, and also let the player craft guzheng as the main mission of the first chapter. So here is our main gameplay loop. So the player starts to walk around the game environment, which is a Chinese street environment, and you can choose to talk to NPC and to interact with the environment. After that, you may gather some crucial information about clues and missions. Also, if you interact in the environment, you are going to learn a new word or new melodies. And after you receive a mission from NPC, you can go to the music-driven puzzle game. It's like a mini game, and after that, the player is going to get a crucial mission objective, also a crucial word that is important to the mission. And here's our current design of the game map. So the main quest in the first chapter is to gather the guzheng as the main instrument, and this goes into several missions. So first, at the beginning of the scene, this is the player start, and you are walking to the old lady who used to be a guzheng maker. And this is the first tutorial section of the game. And after you complete the tutorial section, she will give a list of materials needed to craft the guzheng. And this is designed like into a parallel mission structures, which the player can choose to complete in any order. And after each object completed, you will unlock a new piece of story from the old lady. And at the end of the game, you will complete other missions by gathering all kinds of materials. So I'll show you an example of the mission structure. So for example, if you want to obtain a gut strings, which come from the sheep, so you need to first talk to the butcher in the town, and however, at that time, you never get the word of the vocabulary gut strings. So the butcher will give you a mission, so you are going to complete a short mini game, which is helping the butcher's son in the shepherd. And after that, you are going to learn the word sheep. And after that, you return to the butcher, and you can, at that time, you can have the knowledge of saying gut string. So the butcher will give you the gut string, and you complete the mission.
Okay, so other than game design and development, we also made some significant progress in character art and environment art. So for environmental art, we started documentary and records on Nanzhao in Yunnan, summarizing its residential styles from 1,200 years ago. Based on well-preserved villages today, we refined the design, and the final output includes 4 sides of residential models with modular parts allowing for more combination as needed. And here is an example of 2D art for the puzzle to get the sheep mission. In this puzzle, you will help to drive the wolf away and guide the sheep back into fence. When figuring out a puzzle, the player can play different melodies they have learned to interact with game object. For example, if you play fire melody to the firewood, you can start the fire and scare wolves away.
So this is the main character, and the main character design is overall based on the original concept design, incorporating historical records for clothing cuts and local characteristic patterns, along with a golden crown to signify his status. So these are his animation, including a walking idol, nodding, and shaking heads. This is our main NPC, the guzheng maker. This is the design of the guzheng maker in her 40s. Due to the hardship of life, she appears like this. Her clothing and hairstyles are reference to historical records. We initially started the cloth animation using an Unreal Engine plugin, Chaos Class, by copying the weight of the character to the clothing. But since most Asian clothing consists of skirts and drapery, using cloth simulation achieves better visual results. So this is the simulation using Houdini.
So let me introduce the audio designers of our game. According to Chinese music history, Chinese music from our target history periods is in a pentatonic music system. And each symbol represents a unique notes. So we use this as an inspiration to create different combinations of different meanings. So let's hear some demos of different sound. So why we use flute? According to our story, the protagonist travels around the country, so it's relatively hard for him to carry large instruments and walking around. And even though the typical flute is in a higher range of sound, there are also lower range sound flutes, so it's easier for us to create more harmonic music. In addition, according to the history, the flute has existed for a long time, even before the Tang dynasty that we're looking for. So there are plenty of resources and references that we can utilize. And also, it's very popular still right now in those bands. So if the game rises players' interest in them, they can easily get 109. These are the melodies that we create and implement in the game right now. So during the quarters walk around, we've received feedback that it's better to let audience feel and the emotion evoke by the music. We took that advice seriously and implement in our audio during the process. For element melody, each of the melodies started with the corresponding elements and expressed the typical emotion carried by the element. Let's hear the example of the fire and wood one. So this is the fire one. We want it to be more fast pace. So it's like the typical like fire. And this is the wood one, more peaceful. And there are also some melody that represent a theme, like a ship melody here. In this case, we make the music, the melody sounds like the stereotype of the item. We've also attended 2 Tuesday playtest nights. We scheduled playtests with feedback with 3 faculties, and within ETC, we've got a total of 16 playtesters.
So we receive a lot of feedback from the playtesting sessions to discuss and make some design decisions. So originally, the game's the only way of using music in our game is to communicate. And the clicking to walk around the whole map is our main gameplay control, and the players have to manually input the notes in order to keep the memories. And after we took this to the playtest, player feedback is that the players feel bored very quickly after several interaction loops. And also the music feels too mechanical because people only use the music for puzzle solving without feeling the music itself. Also, as designer ourselves, we found out there's very limited space for puzzle design in the original idea. And after that, we make the design decisions to shift the puzzle design into a music-driven minigame. And in the game, the music can be influenced the world surroundings, and the players can play part of the melody to generate unique tones based on the melody elements and different emotions. And we took this version of the idea to the playtest, and we received a lot of positive feedbacks that players feel more influential and free in the game world. And also, people can sense the emotional change when playing different music and different melodies. And by receiving these positive feedbacks, we aiming in this direction for the design and the next steps. So these are the progress we've completed so far. And between the spring break and GDC week, we will take the feedback we got from Halves and elaborate our future tasks. And before the playtesting day, we aim to finish all the gameplay functions for the rest of missions, also finish the art and the visual effects, to implement the sound effects. Also, the most important thing is to keep playtesting with our audience and iterate our design. So in summary, our project is a music-driven puzzle game inspired by Chinese folk music, and we aim to spark interest to learning music within cultural context. Thank you. We are open to questions. Any questions?
So very much at the center of your game is the experience of playing the music. How are you feeling in terms of your playtesting? Is that experience of playing the music and playing the melodies, is it delivering the experience you hoped?
I think at first we building a paper prototype, and we make a PowerPoint before we implement those in Unreal Engine. So at that time, I think the player feel less about playing music, but more about solving puzzle itself. They cannot sense it's playing music and feel the music emotions. But after we implement the second iteration, also we implement the gameplay function in Unreal Engine. The player can click 1, 2, 3, 4, 5 for different 5 notes and to compose different melodies. And in that version, we feel the player gave us feedback that they feel like they're playing the music by themselves and express their emotions.
Question about your cultural context. So, with your playtesters, do you notice them, are they approaching this more as, let's solve these puzzles and get through this game? Or do you notice some people actually generating curiosity about the cultural context? And how do you plan to encourage that?
So do you mean by like for playtesting, do you find like people are curious about like the cultural context in the game, or?
Are you noticing it? How do you plan to measure it? And do you have any strategies towards to actually enhance it? Because it sounds like that's what you're going for. So how do you plan to really step on the gas and get that going?
Oh yeah, I think that's kind of our major objective for future playtesting. So in the past playtesting sessions, we kind of more about letting player test like the function, like the music puzzle solving process, without implementing like too much like narratives and like cultural context. So the player may feel like didn't feel much about that, but after we going to implement those narratives and to the game, the player is going to feel like more about like it's a storytelling.
I was a bit confused by the use of the elements for notes, and then also, I think, the use of some of those same elements to solve puzzles, like fire. And being extremely literal, I might think the way to compose a fire melody is just fire note, fire note, fire note, fire note, and I'll get fire expressed extremely strongly. So, from your playtesting, is there any such confusion, or is everybody else clear on this, that you mix these elements to compose melodies that might just be a single element anyway?
So when we compose the fire melodies, we are like the melody pieces started with a specific elements, and then the later part doesn't really connect with the melody, but we just make it sound like the stereotype of the melody. But we have the first melody, first elements indicated like which melody it is.
Hi, so there's a slide that you show. You can make up words with the elements you have to represent like the meaning of meat and something else. Like my question is like, how does the combination of the symbol has inherent meaning, and how are you going to use those words in the later puzzles?
So to explain that, so kind of in ancient Chinese history, like each of the 5 elements are corresponding with like different things. So each element is going to have like a deeper meanings around that. So we kind of built that from like inspirations. We took inspiration from like the real theory and history, and we kind of make like a dictionary by ourselves. Like our designers try to combine with different elements to make sense the most.
That's time. Thank you, team.
Thank you.
Okay, hello. We are Team Strangers, and this is our half presentation. So this is the team members. So this is Marsh, our 3D artist, Tyler, our programmer, Ivy, our UI UX and 2D artist, Ryan, our game designer, and Xiaoxin, our VFX designer. And my name is Harry. I'm the producer of the team. So our instructor is Mo, and our client is the Physical Intelligence Lab here at the Carnegie Mellon University. So to put things short, our goal is to design an extensible research tool embedded with game elements in order to collect data of people doing unfamiliar motor skills. So we should be providing a playground for them that introduces these unfamiliar behaviors to the player, and then we collect data from their practices. So to better explain this, actually our client has been collaborating with the EDC before. So a year ago, there was a project called the Gesture Quest, and Tyler was on their team as their programmer. And so they were teaching people how to do sign languages, which is an example of the motor skills. The game design allowed the client to manipulate the parameters and collect data, which is a sample of the extensible research tool. So we thought we could use their pipeline, except that as the project name, music dexterity quest, and also the team name, Team Strangers, indicated, we are supposed to do this by teaching people how to play ukuleles. But if you remember this from our quarters presentation, we have encountered a huge technical issue. So we were supposed to build our own machine learning model in order to detect hand shapes and chord shapes when you're playing the ukulele. But we found out that after the model was trained, the precision of this model will not be able to help us to determine how precise that the chord you're playing is. So given the scope of one semester, we don't have enough time to tune the model to make sure that precision is acceptable for a research purpose. The occlusion of the instrument and the video quality of a webcam turned out to have a huge impact on the motor skill that really requires precision. So after long discussion with our instructor and also our clients, we have all agreed that we are shifting the subject from ukulele to something else. And that will help us deliver a product that everybody is happy with. So this is a decision made by the end of week 4. And after that, instead of building our own machine learning model, we started with something that has already been verified, which is the face detection. So this is a technology from Google Media Pipe that allows us to identify the movement of your head, including the direction, and catch certain movements of your eyes and mouth. So with this subject being changed, we are treating this as a brand new project, only that it starts from week 5. And for that, we need to brainstorm again, and knowing the need of our client is really the essential part of it. So ukulele had its own rule. As a musical instrument, it has lots of restrictions indicated in itself when you're holding it in your hand. But now we are designing a game that has no such inner rules. And what we already know is that our client is expecting that this is a game that forces people to do unfamiliar motor skills, and so that they can do research on it. And what else?
Yeah, so how to clarify the client's needs? We did it through like game pitches. So as a team, we made a lot of open-ended game pitches. For example, this one, we asked players to use their head and face to control a spaceship that's roaming around the space. And next, we have a game that requires players to do different funny expressions. So anyway, there are just some examples. We have 9 more pitches similar to these 2. So, and by making these game pitches, we enable client to refine these game ideas, thereby helping us understand the requirements. So what are the requirements? The first thing is about the game data. Basically, we can provide 2 different types of data to our client, discrete and continuous. So according to our client, the game should focus on collecting continuous data from players' inputs while also capturing some discrete data. Given that to our game, continuous means that our player has to move continuously along a specific track throughout the game. For discrete, it could mean some discrete placed along the track. So next is about the game content. So the client really wants to use clear rules to strictly judge if players' behavior is right or wrong. So in that case, our game content should be clear and direct, which means one way to counter each mechanics, one task at a time, one clear and direct goal for our game. So in all, our game is less about strategy and multi-options. And now we can summarize our clients' needs. First, clients want our game to be simple and clean, no fancy image effects. Second, our game should focus on collecting continuous data with some discrete data. Last, our game experience should be clear and direct. It should be less about strategic. So knowing the needs, now we can move forward.
After spending an amount of time to reset our project and clarifying the client's needs, we need to have a playable prototype which is good enough to satisfy all of the client's requirements and also been able to build before Halves. Therefore, we started rapid prototyping each week do as much as we could to improvise any changes based on our client's feedback. After some brainstorming with the team and approval from our clients, we started to build our first prototype, which is a spaceship game. Here's a quick demo of the game. The game is designed based on limited controls with continuous movements from the players using their faces. We designed this game to focus on having a one-to-one mapping between face movements and controls. Focusing on simple goals and clear targets, we were able to bind a desired goal we asked the player to achieve with a motor skill using their faces. Enabled to strengthen the mapping for our players, we utilize the space on the side to show the mapping of the face expressions and the game controls. After discussing with our client, we went through some revisions and came out with a more simpler design for our client's research settings. By cutting off visuals and amplifying the introductions, the screen is now cleaner and the player could now focus more on the instructions. Based on the feedback from our clients and some playtesters, we found out the control mapping we designed is easy to pick up. Some playtesters also found satisfying in our shooting mechanic, which provides instant and tight feedback between face expressions and game interactions. Although we provide player with limited freedom, right now the game is still open-ended, which allows players to solve problems in ambiguous ways. For example, when encountering an enemy, players can choose to evade or shoot the enemy, making the outcome of each play different. According to our clients' needs and research purposes, this is hard to calibrate compared to a predefined path where performance can be measured against one and only one correct solution. Another observation is that when the player is using their head for directional controls, rotating the head to move left and right makes it difficult for them to look at the screen, while nodding up and down sometimes tampers the detection result and accuracy. Last but not least, we found out that controlling a spaceship with only facial movements alone lacks tight connections, since player will be constantly thinking about facial expressions. Instead of immersing in the game, this approach makes the gameplay not very engaging compared to controlling something with a more visual, intuitive feedback. Furthermore, we gained a clear vision for the capabilities of the current face detection technology, despite having somehow a considerable amount of interactions available due to the limitations for consistent playing environments for our platform. We narrowed down our controls for our game to only use conspicuous actions, such as rotating the whole head and open-close movements for our jaws, which then leads to our second prototype.
And for this prototype, it still relies on traditional STG game mechanics, but we mainly make two changes. First one is that we constrain the navigation path to guide player directly through a fixed route, which, for example, narrowing the map to define a path. And second one is that we remove the back and forth control, making the control target to move forward automatically, while player will be tilting their head to adjust the forward direction. And to test out these ideas, we quickly come up with a travel circuit. And the player's goal is to reach to the endpoint without hitting the boundary. And here's a demo video in which this one is when the player first makes some early attempts at the gameplay, which they're having a hard time overcoming the first turns since we're not really familiar with head control directions. And after a few tries, players can progress much more further and could even overcome some continuous sudden turns. And as players, because they are gradually mastering head control and the route itself. But unfortunately, I still did not finish this end route. I died here, yeah. So based on the playtest, we found that this version had a couple of takeaways. First, it better fulfills the client's need by shifting from allowing diverse player strategies to focusing on training unfamiliar motor skills. So progression is now tied to getting used to the head-based control and memorizing the level. And second, tilting head is much more accessible and at the same time still requires some progressive learning. But we need to playtest more to fine-tune the parameters. And lastly, this version enables scalable difficulties. Originally, we planned to design different maps to leveling up the complexity. But through playtesting, we found that just navigating solely with your head is already challenging, even without any obstacles we envisioned, which means one single map can have multiple levels. For example, the first stage could just be a fixed path and like the current prototype. And the next is adding one single puzzle that responds to one face expression as a solution, which introduces the discrete detection. And more incorporating multiple puzzles that require solving each of them with different expressions. And bringing these design concepts to the game theming, we retained the original idea of
a character in traveling through the space. And keeping in mind of constraining the path, the player will be like surrounded by dangerous meteorites and traveling along a path that is in order to safely get to the destinations. And another approach is to provide a road, which makes the path even clearer. And on this journey, not only you cannot hit any boundaries, but also you may encounter some friendly units that you can collect or obstacles that you need to avoid, and all requiring some phase reactions as discrete detections. And together, by making all mechanics configurable, this iteration could better fit with the main goal of adapting unfamiliar motor skills.
Yeah, for art styles or art asset originally designed the airplane universe world, we start with the asteroid as inspiration. So we want to do space sci-fi style theming. The character the player control in design as spaceship, and its mission is to dodge space meteorites and destroy UFOs. And at first, design is STG game, and our layout is vertical view, but our design is a limited frame, and our original art set looks very tiny when we put in. And also, we feel that controlling the airplane with the face is not intuitive. And in order to increase the sense of the immersion, we are going to change the airplane to a face-themed character. We designed the player main body has changed from an airplane to a cute ball-shaped creature. The player can control the movement mainly by facial movement and head offset. And we decided to use cute character when shifting our direction to a low poly, vibrant color, looking better in our game layout. We believe this also fit in more to our young audience preference, which is an accept of client need. And we decided to go ahead and design some decorations to fit in our game sense. For example, this planet, for the discrete detection, player need to do certain face expression to eat those planets as one of their goals. We designed not only eating planets, but also recruiting astronauts in the space travel journey, which will be added to the future game design as another example discrete game mechanics.
And after we show our process to our client, what we get from them is that wonderful prototype looks like it is on track. And since this is a reset project, we have limited time. Under this situation, we should quickly move into our production. The good news is that our current direction has recognized by our client. But our goal is not only to deliver a game, we also need to make sure to document everything and allow configurable designs so that the clients can use it for future research use. So we must balance the schedule between production and these other problems. Here is our plan. Firstly, for our game and our part, we will add more levels and refine existing ones, expand our art assets while keeping in mind that our client prefers a simple and clean design to avoid distracting our players. For our research part, we will allow more game parameters to be adjustable for fine-tuning, support our clients' research needs, and ensure the game is scalable. And also enable data transmission to their server, provide technical documentation for them. With these steps, we aim to deliver a more polished and a functional game while aligning with our clients' expectations. And this is our timeline for after Halves. From week 7 to week 10, we will be mainly focused on developing and expanding our game, add more content and refine experience, prepare for our playtest day on week 10. And we are strangers, thank you. Now we are open to questions.
Okay, I got two completely different questions. One is at the end you talked about configurable parameters. Are you essentially talking about a level editor? Will you be able to load in new assets to create a pathway that the player would follow with their head and putting the discrete obstacles in the way? Other question is, you briefly showed a character design beginnings of one that looked a little bit like a ghost with an excited face. are those going to mirror the player's facial reactions so that they have an immediate thing and it's not just waiting for a response from the world?
Yeah, so for first question, we did think about level editing, but our client says that just editing the parameters like your velocity of the thing that you're controlling and the angular speed of its rotation, and that would be the most direct parameters to be configurable. And the other than that is mostly like the position. They would like to collect more data of like where the position of that the player have failed and where they the number of trials that they have been doing and the reaction speed is mostly about that rather than focusing on the level editing. And for the second question, yes, we are just working on how to sync the facial expression to that 3D model for the character. And we just got the face mesh that is based on the webcam detection, and it's going to be reflected onto that mesh, and we're trying to sync that with the 3D model. So yeah, that is in the plan.
The client likely is interested in game data and understanding what the player is doing when, and just having a stream, maybe something they can replay later. What are you using for your in-game metrics collection? Because I'm curious. Are you collecting timestamp data for what the player is doing?
Well, we haven't actually started on that process yet, but based on our client's instructions, it's like just collecting the the number of trials and how far they have been going on each times of trying, and also that where they fail. And I think that those, and also that the data from your facial expressions and the reaction time from they are seeing certain obstacles in their view and how fast they react to that. It's mostly about those parts.
How are you going to make your name relate to your new project? Now that you're following along a path, along a string, it seems like there's obvious ways to make that happen.
We are going to plant some Easter eggs where that things are held in a ukulele and they just are floating around inside the background of the game, so that you keep in mind that this game is made by Team Strangers.
Thanks, team. And that's it. Thank you, everybody. We get the head off in green. Thank you.